Okay, so got that going. We're reviewing our test. So I just went over that the answer for the first one, in case you're back watching this, is 7b plus 4 plus 2b plus 5b squared?
Yes.
Plus
B
plus b to the power 4. That was the answer? Okay, yeah. So that's the first one. Okay, moving on to problem 2. So problem 2 asks us to factor this expression. We've got everyone. Thank you. Okay, factor the expression. We factor by grouping, and 99% of the time, I'm going to be nice enough to you that they're already grouped. So you factor the biggest thing you can out of these, and you factor the biggest thing you can out of these. So looking at these two together, what's the biggest thing that they have in common? N squared. They both have an n squared. This has 3 n's, this has 2 n's. So factor that out, we get n squared times 3n minus 2, right? That's just these two terms. What can I factor out of these two terms? 3. I'm going to take out the negative 3. You could have taken out the 3 and see that you need to plot the negative sign. I'm going to take out the negative 3. So negative 3, when I take negative 3 out of this, what am I left with? Positive 3n, right? And when I take negative 3 out of 6, what am I left with? Negative 2. If you're ever wondering, just re-multiply it out in your head. Say, what's negative 3 times negative 2? Positive 6. Okay, we're good. So you can always check the signs that way. All right, now we see same thing, same thing. So now I can factor that out of both these terms. Now I can pull it out this way or pull it out that way. It doesn't matter which way you pull it out. And either way, you're going to get, so pulling it out in front, we get 3n minus 2 times n squared minus 3. Again, if you're wondering, did you do it right? You can always just redistribute everything out, and you better get back where you started. You can take the 3n, multiply it to that, take the minus 2, multiply it to both, add it all up, see what you get. You should get back where you started. But here's your answer. This is completely factored. So we factored by grouping. Took the greatest common factor out of those two things, till we got what was left the same, and then pulled it out. Common strategy. Next one. Problem 3. Factor the expression. When you have 3 terms, we can't factor by grouping. Factor by grouping is for when we have 4 terms. When we have 3 terms, what do? We're looking for our magic numbers. So this is going to be x something, x something. What are we looking for? We're looking for 2 numbers that multiply together give me negative 18, and added together give me negative 7. Now since they multiply to negative, I know one has to be positive, one has to be negative. And my 2 numbers multiply together give me negative 18, add together give me negative 7. That's positive 2 and negative 9. 2 times negative 9, negative 18. 2 plus negative 9, negative 7. Any questions on that? All right. Next. This is one where I hope you would see the pattern and just be able to crunch them all out. So first off, a squared minus b squared is always and forever equal to a minus b times a plus b. Okay, now we have a to the 4 minus b to the 4. Well, that is the same thing as a squared minus b squared squared. So it's something squared minus something squared. That is always and forever equal to the first thing minus the second thing times the first thing plus the second thing. Exact same thing we did up here. Something squared minus something squared is always equal to the first thing minus the second thing times the first thing plus the second thing. Something squared minus something squared is always and forever equal to the first thing minus the second thing times the first thing plus the second thing. Now it turns out this can be factored again exactly how we did it up here. A squared minus b squared is a minus b times a plus b. So your final answer is a minus b times a plus b times a squared plus b squared. Yeah? Yeah. Cool. Similar trick right here. You can just use this exact formula that we have above it if you want. This is now x to the 4 minus 2 to the 4. And something to the 4 minus something to the 4. You just plug in that for a, plug in that for b. You can just use the previous problem if you want. So this is just equal to our a. We replace a with x and we replace b with 2. So our a is now x, so it's x minus 2 times x plus 2 times x squared plus 2 squared, which is 4. See it? Okay. And then finally, the last one. This again is 2x squared minus 6 squared. Something squared minus something squared is always and forever equal to the first thing minus the second thing times the first thing plus the second thing. Now, you notice that there's a 2 in there and a 2 in there, factor it all out. A smarter way to do this would have been at the beginning, always see if you can factor something out first. So I could have said 2 comes out of this, 2 comes out of this, and I could have said it's 4 and then continue factoring out. But a smarter way would have been factor out the 4 first, and now this is 4 times x squared minus 9. And now it's 4 times x squared minus 3 squared, which is equal to 4 times the first thing minus the second thing times the first thing plus the second thing. So if you factor 2 out of both these, factoring 2 out of that would give you that, factoring 2 out of that would give you that, multiply them together you get 4 dot these two things after. Same thing. With me? As a general rule, anytime you factor, always and forever, you want to start with looking at and seeing if there's a greatest common factor you can pull out of everything. That's always your step 1. Typically it makes the number smaller, easier to work with. Alright, for round 5, solve the expression. This time we're looking for what x is equal to. This one, I think pretty much all of you got right. So this one, we have x squared minus 8x. I'm going to bring the 3 over. I'm going to add 3 to both sides. So if I add 3 to negative 3, that's 0. If I add 3 to negative 3, that's 0. So we're just left with is equal to 0. Right? Adding 3 to both sides. Now factor the x out. And we get x times x minus 8 is equal to 0. So this is equal to 0 when either this is 0 or this is 0. What value of x makes x 0? 0. So x equals 0 is one answer. What value of x makes x minus 8 0? 8. X equal 8. These are your two answers. If I plug in 8 for x, we get 0. If I plug in 0 for x, we get 0. Those are the two values that give us 0. Any questions on that one? All right, moving on to problem 6. Simplify the expression. Hint, the numerator is not 0. So when you cancel out something with your numerator, don't write 0, make sure you write 1. All right, so this is equal to, our numerator, we can't factor that, so that's still x plus 1. But our denominator, we're going to have x and x, two numbers, multiply together, give me 7, add together, give me 8, and obviously that's going to be plus 1 and plus 7. Now we cancel out the x plus 1, top and bottom. When you cancel out x plus 1 top and bottom, we leave a 1 at the top. So that could have been written as 1 times x plus 1 if you want. Don't forget that. That's 1, not 0. So it's 1 over x plus 7, as opposed to 0 over x plus 7. Make sense? Okay. Similar thing. We're multiplying these two terms together. Now you can take the bull by the horns and do all the messy algebra, or you can start canceling out like terms top and bottom. I've got a 6x in the top, 6x in the bottom. You can think about this as having parentheses on it. I've got an x minus 3 in the bottom, x minus 3 in the top. I've got an x minus 6 in the top, x minus 6 in the bottom. When it's all said and done, I'm left with x plus 4. So this is just equal to x plus 4. Really simple, right?
I think what confuses that there's a separation between that one was being times by the others. I didn't know that you could cross cancel with two different. Never mind. I get it.
Here's another way you could have thought about it. When you multiply two fractions together, what do? You multiply the whole top by the whole top and the whole bottom by the whole bottom. So if we multiplied it first, we would have gotten 6x times x plus 4 times x minus 3 times x minus 6 all over x minus 3 times 6x times x minus 6. So if we multiply it first, it looked like that, and then you can start your cross canceling, and you're going to get the exact same answer.
Okay, yeah. That makes
Okay. This one, I gave you guys all credit for because I wrote the problem wrong.
Oh, good.
And I understand why many of you got confused. That was not supposed to be a times, that was supposed to be an equals. This is equal to that. Find the value here that makes it true. That's what I meant to say. Sorry about that. So you all got full credit on problem 8, no matter what you did. So how would we have done this problem? We would look at this over here and factor it, and we notice that this is the same thing as looking for two numbers, add together, give us 5, multiply together, give us 6. That's x plus 2, x plus 3. You with me so far? This is just factoring that. So notice that to get this denominator to equal this denominator, I have to multiply it by x plus 3. So to get this numerator to be equal over here, I also have to multiply it by x plus 3. So our numerator would have been x minus 4 times x plus 3. That would have been the answer. Or you could have multiplied it all out and I wouldn't have cared. You could have written it as x squared minus x minus 7 if you wanted, and that's fine too. Minus 12. Go ahead.
So when you're factoring out the bottom, you need two numbers that equal 5, but also you need
Two numbers that add together to give you the middle, and multiply together to give you the end.
Okay.
Yeah, that's what we keep doing every time I'm saying, looking for the two magic numbers.
Okay.
And notice that if we were to re-multiply this out, look at what happens. So x to x right here, that gives me, x times x is what gives me back this x squared. When I do the x to the 3, that gives me 3x. When I do this 2 to the x, that gives me 2x. 2x and 3x gives me 5x. So notice those two numbers have to add together to be this number.
Okay.
And then I'll also do a 2 times 3 to give me 6. So those two numbers multiplied together have to be that. Multiplied, give you that, added, give you that. That's the logic.
Okay.
Cool. Alright. Sorry, was there any more questions on that one? Kind of just erase the work and ask. Okay, adding fractions. For the love. Where you guys all have your kryptonite. Adding fractions together. When you add fractions together, you have to get a common denominator. So we're looking for the least common multiple of 8 and 12. What's something that 8 and 12 both go into evenly?
24.
24. So to make this a 24, what do I have to do?
Times it by
Multiply it by 3. Now I don't want to change this number, otherwise we're changing the problem. If I ask you what's 1 plus 2, and you say, well, if I take this 1 and I multiply it by 3, then 3 plus 2 is equal to 5. That's not what I asked. I said what's 1 plus 2. So you can't just go and multiply the bottom by something without also multiplying the top by it. Because then you don't change the number, and it's still the same problem. So we multiply top and bottom by 3. So I'm multiplying this to this. Put parentheses if it's confusing you. Now that's going to give us a 24 down here. What do I need to multiply this by?
2.
2 to get our 24. So I need to multiply this one top and bottom, put parentheses there if it's confusing you, by 2 over 2. Now when we do that, let's work this out. What's 3 times x? 3x. What's 3 times 5? 15. All over 3 times 8? 24. And we're adding 2. 3 times 2 gives us 2x minus 6 all over 24. They have a common denominator, so now we can just add it. So now, if I have 3x and 2x, I have 5x. And 15 minus 6 is plus 9. All over 24.
Okay. Is that the answer?
That's the answer. 5x plus 9 over 24.
Okay.
Cool. Alright. One that's a little bit more messy. We've got one fraction divided by another fraction. How do we divide one fraction by another fraction? You multiply by the reciprocal. So I take this and multiply by the reciprocal of that. So I'm going to take my top fraction, which is a squared minus b squared all over 4a squared times b. And I am going to multiply that by the reciprocal of this. So I'm going to multiply it by 16ab squared all over a plus b. If you're getting confused, always put your parentheses on each of your fractions. Good so far? Now, notice what we can cancel. I can cancel the 4 and the 16, leaving me 4. I can cancel an a and an one of my a's, leaving just one there. And I can cancel my b and one of my b's, leaving just one there. With me so far? So let's rewrite out what I have, and notice I can also factor this. So I'm going to factor this really quick. A minus b, a squared minus b squared is the same thing as a minus b times a plus b. So I got that factored. We canceled out 16, leaving just a 4. We canceled out the a completely, and we canceled out one of our b's, leaving just one b. All over in the denominator, we canceled the 4 with the 16. We canceled out one of our a's and our a squared, so we just have a left. We canceled out our b, and we have times a plus b. Finally, notice that a plus b cancels top and bottom. And so we're left with, I'm going to write the 4b first. So it's 4b times a minus b all over a. I know some of you split that into two fractions. It's preferred to keep it together in one fraction. Like this. Any questions on that one? All right. Good?
Yeah.
Okay. Next one. Cross multiplying. Some of you tried working through this the hard way. When you have a fraction equal to a fraction, the product of these two is equal to the product of these two. So, cross multiplying is what it's often called. I'm going to multiply these two, and it's going to be equal to the product of these two. So 8 times, don't forget your parentheses, x minus 8, is equal to 5 times 3 is just 15. Now distribute the 8 through, we get 8x minus 8 times 8 is 64 is equal to 15. Now we're going to add 64 to both sides, and we get ax is equal to 79, or in other words, x is equal to 79 over 8 when we divide both sides by 8. Good? Any questions on that? All right. Next one. Bit more complicated. You know, move that up a little bit. So first thing, really quick notice, x squared minus 4 is the same thing as what? That's a perfect square. That's x squared minus 2 squared. So it's x minus 2 times x plus 2. So what I'm going to do is I'm going to multiply every single term by x squared minus 4. What I do to one side, I'm going to do to the other side so it doesn't change the equation. So I'm going to take this term, and I'm going to multiply it by x squared minus 4, or in other words, x minus 2, x plus 2. So I'm going to take this term, multiply it by this. I'm going to take this term and multiply it by it. So I'm also going to take it and multiply it by x minus 2, x plus 2 to this term. And I'm also going to multiply this term by it. I'm going to take this, I'm going to multiply it by x minus 2, x plus 2. Understand what I did? Yes. I multiplied everything in both sides of my equation by the same number. That's perfectly valid. If I know that 1 plus 2 is equal to 3, I can multiply everything by 5 and it's still true. I know that 5 plus 10 is equal to 15. I multiplied everything by 5, it doesn't change anything. I took each one of these and I multiplied by the same number. Doesn't change anything. Why did I multiply by that number? Well, first off, x minus 2 times x plus 2 is x squared minus 4. So these cancel out with that. So we got rid of that denominator. Over here, x minus 2 cancels out with the x minus 2, just leaving the x plus 2. So that cancels out with that. X plus 2 cancels out with the x plus 2, leaving the x minus 2. That cancels out with that. And so it gets rid of all our denominators. And so now I have x minus 2 times 1, which is x minus 2. Plus, I have x plus 2 times 1, which is x plus 2, is equal to, I have 3x plus 8, because our denominators are all completely canceled out now. So that's why we multiply by that magic number. Gets rid of all our denominators, makes this problem much prettier to work with. Now, put all your x's on one side and all your constants on the other. Well, first let's really quick simplify this. X and x gives me 2x. Negative 2 and positive 2 gives me zilch. So this is equal to 3x plus 8. Okay, now I'm going to move all my x's over here and all my constants over here. So I'll subtract 2x from both sides and subtract 8 from both sides. Over here we're left with -8. Over here we're left with x. X is equal to -8. Okay. Next one. Converting square meters to square kilometers. So I have 435,000 meters squared. Meters squared is the same thing as meters times meters. Meters squared. With me? I need to get this into kilometers squared. So I need to cancel out my meters. So I need to multiply it by a 1 that has kilometers in the top and meters in the bottom, so I can cancel out my meters and replace it with kilometers. Now 1 kilometer is how many meters? How many kilometers, how many meters are in a kilometer? 1,000. So 1 kilometer is the same thing as 1,000 meters. Notice that I'm taking this number and I'm multiplying it by 1. I'm taking the same number divided by the same number. That's just 1. A kilometer is 1,000 meters. Same thing. We didn't change anything. You with me? And now that meter cancels out with that meter. We still have another meter to cancel. So let's do the same thing again. Multiply by 1 kilometer over 1,000 meters. Now that meter cancels out with that meter. Multiply across the top, and what do we get? We get 435, we get this, kilometer squared. So 435,000 kilometers squared, all over 1,000 times 1,000, or 1 million. Now, just write that in decimal form. Or in other words, shift your decimal place this way 6 times. So this is equal to 0.435 kilometers squared.
I just forgot.
Okay. Next one, taking radicals. Okay, square roots here. So, 98, I have that under the radical. The only way I can get something out of this square root is if I can find a perfect square. Square roots cancel out squares. So, we notice that 98, what's a perfect square that goes into 98? Let's think about our common list of perfect squares. What are our perfect squares? We have 4, 9, 16, 25, 36, 49, 64. Probably good enough for what we're after. Okay, question, does 4 go into that? No, it goes into 100, so it must go into 96, so it can't go into 98. Does 9 go into that? No, it goes into 90 and 99, not into 98. Does 16 go into that? No. Does 25 go into that? No. 36, no. 49? I wouldn't have paused unless it did, right?
Yes.
Yes. So this goes into 49 and 2. Now 49 is what?
Is 7 squared.
7 squared. So this is 8 square roots of 7 squared times 2, or in other words, 98, times m times n. Now, since we have a square, we can cancel it out and cancel out the square and pull that number out. So I can pull my 7 out. So I'm going to pull my 7 out. What's 8 times 7?
56.
So this is going to be 56. That's me pulling my 7 out and multiplying it by 8. And now we pulled out the 7. We're only left with the 2mn. And there's your answer. Make sense? Just find our perfect square, rewrite it as a square, pull it out, which gets rid of the square. Okay, problem 15. Almost the same thing, but now we're working with cubes. Okay, our perfect cubes. What are our perfect cubes?
16.
What's 2 cubed? What's 2 times 2 times 2?
6.
What's 2 times 2 times 2?
8.
8. So there's one perfect cube. What's 3 times 3 times 3? Try again. 27. All right, what's 4 times 4 times 4?
64.
64. Perfect cube. Oh, lucky us. That's the exact number we're looking for. So we're going to rewrite this. This is 8 times the cubed root of 64 is the same thing as 4 cubed times u to the 5 times b cubed. Now, if I want to pull a number out of a cubic, I have to pay 3. I have to pay 3 in my exponential. So I can pull the 4 out, getting rid of all 3. I can pull a u out, leaving behind 2. I have 5. It takes 3 to get a u out. That leaves 2 in there. And I can pull my v out, leaving behind none. So this is going to be 8 times. I pulled my 4 out. I pulled a u out. I pulled a v out. Times the square root of. We pulled all our 4s out. There was nothing left. Our u's, there was still 2 left. And our v's, we pulled them all out. There was nothing left. And then finally, 8 times 4 is 32. So this was 32 uv times the square root of u squared. Would have been your answer. Good?
Yeah.
All that makes sense?
Yes.
Sounds like it's good for Dan. All right.
Good.
Keep on going. Okay. This one, same thing. 2 is definitely not a perfect square. Does 8 have a perfect square in it? What's the perfect square in 8? 4. So this goes into 4 and 2. Does 18 have a perfect square in it? 9. So this goes into 9 and 2. So we can rewrite this as 3 square root of 2 plus 2 times the square root of 2 squared, or 4 times 2, minus 3 times the square root of 3 squared times 2, or 9 times 2. You see how this is the exact same thing as what we have written out there. Just trying to make it crystal clear what we're about to pull out. So I'm going to be able to pull this 2 out, and I'm going to be able to pull this 3 out. So I'm going to get 3 square root of 2 plus 2 times 2 is 4 square root of 2. So we pulled that out, but we still had this 2. That's where this 2 came from.
Right.
Minus, pulling out the 3 times 3 gives us 9. Square root of, we still have the 2 inside. 3 plus 4 minus 9 is equal to negative 2 square root of 2.
Yes.
All right. Problem 17, simplify. Now, first we'll do this the hard way, then we'll do it the easy way. So first thing we want to do, if we're doing this the hard way, is get rid of the square root in the denominator. What can I multiply this by to get rid of the square root of 15 in the denominator? Square root of 15. Square root of 15. Because what's the square root of 15 times the square root of 15?
Oh, 15, sorry.
The square root of 15 times the square root of 15 is 15. Always and forever, the square root of x times the square root of x is equal to x. What do we mean by square root of a number? We mean the number such that if you multiply it by itself, you get the number. How do I know that the square root of 4 is 2? Because 2 times 2 is 4. So what's the square root of x times the square root of x? Just x. Okay, so again, if I multiply top and bottom by square root of 15 over square root of 15, what do I get in the denominator?
15.
Just 15, perfect. And then when you multiply, you can just multiply the radical to the radical since they're both square roots of 2. So 3 times 15 is?
45.
So this would be 4 square roots of 45. Now, does 45 have any perfect squares in it?
Yeah. This.
5.
5 is not a perfect square. What are our perfect squares?
It has 9.
4, 9, 16, 25, da da da. It has 9 in it. 45 is the same thing as 5 times 9. So we can rewrite this as 4 times the square root of 3 squared, or 9 times 5, all over 15. Now, if we pull the 3 out, it gets rid of the square.
12.
So 3 times 4 is
12.
12. Well, I'll just keep it as 3 times 4. So we have 3 times 4 times the square root of 5, all over 15, right? Now 15 is the same thing as 3 times 5. So rather than 15, I'm going to write this as 3 times 5, and then we can cancel out 3's top and bottom. And so you're left with 4 square root of 5 over 5. Okay, that's the hard way to do it. Let's do this the easy way now. I can cancel out square root of 3, top and bottom, leaving me square root of 5 in the denominator. So this is 4 over the square root of 5. Canceling out square root of 3, top and bottom. And then multiply top and bottom by square root of 5, and we get 4 square root of 5 over 5. Make sense? All right. Geez, how long of a test did I give you guys? Okay, this one. We have two terms in a denominator with a radical. We're trying to simplify, so we have to get the radical out of the denominator. So we're going to multiply top and bottom by its not reciprocal. What am I going to multiply by?
I know what it's called. There's
Close.
a name.
Conjugate.
Yes.
Multiply top and bottom by its conjugate. So 4 plus the square root of 3, or plus 3 square root of 3. And 4 plus 3 square root of 3. And again, always and forever, a squared minus b squared is equal to a plus b times a minus b. So now in the denominator, we have a minus b times an a plus b. So in the denominator, it's going to be a squared minus b squared. The first thing squared minus the second thing squared. So our denominator is going to be 4 times 4 gives us 16. And we're going to have minus our b squared. So what's 3 squared to 3 times 3 squared to 3? What is 3 squared to 3 times 3 squared to 3?
9.
Square root of 3 times square root of 3 is 3. Now account for that 3 and that 3. Try again.
27.
27. So it's going to be minus 27.
Times 9.
It's a squared minus b squared. 3 squared to 3 times 3 squared to 3, 27. Good? Yeah, 3 times 3 is 9. 3 squared to 3 times 3 squared to 3.
Oh.
The 3 times the 3 gives us 9. The square root of 3 times the square root of 3 gives us a 3. And then 9 times 3, 27. Okay. In the numerator, just multiply it out. So 3 times 4 gives us 12. Plus 3 times 3 is 9. Square root of 3. Okay. Now in the denominator, 16 minus 27 gives us minus 11. And we have 12 plus 9 square root of 3.
You can pull that out.
You can put the negative right here if you prefer. That's perfectly good. Fine. Good?
You could simplify it more if you want. Couldn't you?
How? Wouldn't have asked how unless the answer was no?
Yep.
Okay. Next one. Here, we're just going to be doing a lot of adding of fractions. Your guys' favorite thing in the world. When you multiply like terms, you add their exponents. So first off, let's get like terms top and bottom. 2 is just 2. Now, 2 is the only constant in this problem. I don't know how you guys were getting coefficients like 3/2, 5/7, 2 whatever. 2 is the only constant in there. So 2 is going to be our only constant the whole time.
Yeah.
Everything else is going to be x to some powers and y to some powers. 2 is our only constant. So 2 is 2 is 2 is 2. All right. Continuing from there with our x's, I have x to the 2 and x to the 1/2. When you multiply terms, you add exponents. What is 2 plus 1/2? What is 2 plus 1/2? What is 2 plus 1/2? Holy cow.
3 over 2? I don't know.
How many halves is 2?
4.
4 halves. So this is 4 halves plus 1/2.
5 over 2.
5 halves. There it is.
Sorry.
Okay.
Just.
I got to make whole drill sheets of these things for you guys. This is a huge problem. See, the fact that you're saying please don't is telling me yes, I need to. You wouldn't say please don't if it was easy for you. And it needs to be easy for you. We've got to reach that point. It cannot be a difficult thing for you guys to think in your heads, oh, if I have 2 plus 1/2, yeah, that's 5 halves. There's nothing crazy going on there. Okay, so 2 plus 1/2 is 5 halves. So that was adding our x's. X squared times x to the 1/2 is x to the 5 halves. Now our y's. Let's ask a dangerous question. What is 2/3 plus 5/6?
It is 4. Sorry. It is
Close.
How's it not?
9/6.
9/6. 2/3 is the same thing as 4/6.
6, right.
plus 5/6
Oh, I know it is. I know it is.
is 9/6. Alright, got to find somewhere with lots of drill sheets on there. Now 9/6 we can reduce is the same thing as take 3 out top and bottom and you get 3/2. Right?
Yes.
Okay, so this is y to the 3/2 all over y to 0 is just 1. So we can basically just ignore that, treat it as a 1. 1 times anything is just that thing. And now we have x to 7/2. But I need to combine this with this. So I either need to put all my x's in the numerator or in the denominator. Typically, it's better to stick it wherever there's more of them. What's bigger, 7/2 or 5/2?
5/2.
What's bigger, 7?
7/2.
Would you rather?
Yeah, I realized what I did.
Okay, 7/2 is bigger than 5/2. So we're gonna stick that down. If you swap it, if you move it from the numerator to denominator, you make it negative. Same with if you swap it from the numerator or from the denominator to the numerator. So I'm going to move this down, and so we're going to get 2y to the 3/2 over x to the 7/2, x to the minus 5/2. Minus 5/2 because I moved that down. Okay, dangerous question. What is 7/2 minus 5/2? 1. Woot. So this is equal to 2y to the 3/2 all over x to the 5/2, or x to the 1, which you can just write as x. Good? Ready for that one on the midterm?
Yes.
Or on your final, I mean? And then the extra credit one. Extra credit one.
Yes.
We don't like the i's in the denominator, so we need to multiply top and bottom by the complex conjugate.
Yes.
So we're going to multiply top and bottom by 6 plus 7i, and the bottom by 6 plus 7i. Okay, in the top, what do we get? 6 times 8 is 48i, plus 56i squared. All over in the denominator. 6 times 6 is 36. We have positive 42i and negative 42i. Those cancel out.
42i.
And then we finally have negative 49i squared. Now, what is I squared? What's I times I? I squared is equal to what? What? Negative 1. What is I? I, by definition, is the square root of negative 1. What is the square root of negative 1 times the square root of negative 1? Negative 1. The square root of anything times the square root of that thing again is that thing. Square root of x times square root of x, x. So I squared is equal to, this is I squared, is equal to negative 1. So replace our I squared with negative 1s. So this becomes 48i minus 56 all over 39 plus 49, 36 plus 49, which is 85. And there's your answer.
Yes.
Good? Okay. There's a review of our test. Not too bad. All of those going to show up on the final. And you're going to be ready for it.
Just need to work on fractions.
Yeah, that's what I noticed from your guys' test is when it came to adding fractions is where you guys had the most trouble.
Just trying to remember all of them because you have ones for you.
You can multiply straight across and
Fractions are stupid.
Fractions are just stupid.
yes.
Why can't we always deal with whole number quantities of things?
Yes.
Yeah.
Anytime your mom goes slice a pizza, slap her. Say, quit it.
Yeah, I want
None of
whole
those
pizza.
fractions.
I want a whole pizza.
Well, no. If it's just the one pizza, I think Papa gets the whole pizza.
It's just a whole number.
I mean, if we want to.
All right. Okay, back to factoring. We just reviewed a bunch of that. Don't need to do that. What's this after? Quadratics, completing the square. Okay.
This is what we would do.
Now we haven't got to completing the square yet, but both of these, I think he's setting up a review for completing the square. Here's how completing the square works. Let's start with a concrete example before I get into the theory. Come on, just give me an equation. Are you going to give me an equation? No, the whole time you're just going to give.
The answer?
I want you to see it in equation. Okay. But then you have the coefficient there. He's not giving good examples. Sugar. All right, let me give you the concept behind completing the square. I'll make up my own example to the side, kind of piggybacking on one of his, and then we'll go from there. So imagine I ask you to take x squared plus 10x plus, let's see, I divide that by 2 and I get 24. And I'm asking you to solve for the x's on this thing. So when we complete the square, first thing we're going to do is move our constant to the other side. Just forget about that for a second. So it's going to be x squared plus 10x plus something is equal to negative 24. Forget about the constant for a second. What we're trying to do is make this side a perfect square. I'm trying to make this side a perfect square. So I'm almost wondering, what number do I wish was there so that this side over here could turn into a perfect square? Now, imagine what we want this to look like. So when I factor this thing, it's going to be x plus what squared? What do I want this number right here to be? 2 of them have to give me 10. So 5 is what I want here. Now if I put a 5 there, then notice that this number has to be 5 times 5. So I want a 25 there. If there was a 25 right here, then I could factor this whole thing into this. You with me? So what we do by completing the square is I just stick the 25 there, but what I do to one side, I do to the other side. And that's what we mean by completing the square. So now I can factor this. Now this is a perfect square. It's that. And this is equal to negative 24 plus 25 is 1. And now I can take the square roots of both sides. And so now x plus 5 is equal to plus or minus the square root of 1. The square root of 1 is just 1. And then finally we get x is equal to negative 5 plus or minus 1.
Yes.
Or you could say x is equal to negative 5 minus 1 is negative 6. Or negative 5 plus 1 is negative 4. So those are your 2 answers. That's the idea behind completing the square.
Okay.
So that's in a very concrete example. In a more general example, I'm going to have my x squared plus some number of x is equal to some constant over here, c. How do I come up with the number that I want here? How did we come up with that 25?
I'm looking at it the same way.
Yeah, we took this and we said we want this to be x plus 5 squared. How do I know I wanted a 5 here? It had to be half of this number. So I took my b and I divided it by 2. That's how I got this number. And then this over here is this number squared. So I stuck over here b squared over 2 squared is 4. So I added to both sides b squared over 4.
So it's fine. Half is 5.
Yeah,
Square
you-
is that 25.
The coefficients of the x, half it,
Yes.
and then square it and add that to both sides. And you'll be left with a perfect square. So then over here, when we come to factor this, what do we get? We would get x plus b over 2 squared. Notice, what's b over 2 plus b over 2? What's 1/2 of b plus 1/2 of b? B. What's b over 2 times b over 2? B squared over 4. So that plus that gives us back that. That times that gives us that.
Yes.
That's called completing the square. So now we'll go through his examples that he has up here and see what he was after. So here's where he's just reminding us how to solve those types of problems. So example here, x squared plus 8x equals that. I still don't know what he wants us to do. So we'll just skip these ones where I'm not sure what he's after, and we'll just solve the equations. Okay, so moving on to the next one. So using completing the square to solve this problem. Now in ours, we had the x squared term by itself. So first thing we have to do is we need to get x squared by itself. If x squared has a number in front of it, divide everything by that number. So step 1 is divide everything by 2. Get x squared by itself. So 2x squared divided by 2 just gives me x squared. 20 divided by 2 gives me 10x. 48 divided by 2 gives me 24 is equal to 0. Step 2, move your constant to the other side. So now I'm going to have x squared plus 10x, leave a blank, is equal to minus 24. Now I'm going to add to both sides. This is where we can do what we call completing the square. Take the coefficient of x, 10, divide it by 2 and square it. Whatever that number is, add it to both sides. So 10 divided by 2 is 5. 5 squared is, so I'm going to add to both sides 25, 25. And so then over here, it's going to be x plus half of that, whatever that is, 5 squared. That's going to be our perfect square is equal to, over here we get 1. All right, let's do another one. Oh, that's all's work for that. Let's try this next one. We'll write over here. So that was a x squared minus 3x minus 2 equals 0. Okay, step 1, what do we do? Step 1, what do we do?
Get your constants.
Move your constants to the other side. Just forget about it. So x squared minus 3x, leave it blank, is equal to, add 2 to both sides, 2.
And divide afterwards.
Now take our coefficient here, which is negative 3, divide it by 2, and now square it. And what do we get? What's negative 3 halves times negative 3 halves?
3? No. Sorry.
Okay,
I don't know.
we're doing negative 3 halves times, you can put the negatives in the top if you want, times negative 3 halves. When you're multiplying fractions, just multiply top to top, bottom to bottom. What's negative 3 times negative 3?
9 negative.
Positive 9. A negative times a negative
Oh,
is a
right.
positive. Negative 3 gives us 9 over 2 times 2 is
4.
4. So 9/4. So I'm going to add to both sides 9/4. Now I don't even need to think about this anymore. I know it's a perfect square. It is going to be x plus half of that, in this case minus 3 halves, half of the coefficient there, squared is equal to, on this other side, well, we do got to add those together. Okay, scary problem. What's 2 plus 9/4?
2 plus 9/4.
What's 2 in terms of fourths? How many fourths is 2? How many fourths is 2? 6 fourths?
It's more like 8/4.
8 fourths. If you got 2 pizzas and you slice both of them into fourths, how many slices do you have? 8. 2 is 8 fourths. So 8 fourths plus 9 fourths is 17 fourths. So this is equal to 17 fourths. Perfect. Now we can take the square root of both sides. So taking the square root of this, we get x minus 3 halves is equal to the square root of this. Remember, plus or minus, square root 17 over 4. Right? The square root of something squared just gives you back that thing.
Right.
And the square root of 17 over 4. Okay. Now I'm going to move the 3 halves to the other side. So this is x is equal to 3 halves plus or minus the square root of 17 over 4. But I know how to take the square root of 4. That's just, what's the square root of 4? 2. So this is going to be the square root of 17 over 2. Oh, common denominator. So this is 3 plus or minus the square root of 17 all over 2. There's your answer. That was a different problem. Let's see. So he got x is equal to 3 plus or minus the square root of 17 over 2. Yay, same answer. Okay, on to this next problem. On this next problem, we have 3x squared is equal to 2x minus 7. What am I going to do? Get all my x's on one side and get your constant on the other side. So move the 2x over. So I'm going to have 3x squared minus 2x is equal to minus 7. Now what do?
Divide.
Make the coefficient of your x squared term 1.
Divide everything by 3.
Divide everything by 3. So we're going to get x squared minus 2/3 x is equal to minus 7/3. Just divide everything by 3. Okay. Now we can complete the square. Let me leave a space here so you can complete the square. Is equal to negative 7/3. What number do I add to both sides? Half that squared. So what is 1/2 of negative 2/3?
1/2 of negative 2/3.
half of 2/3? 1/3. Because if you have 2 1/3, you got 2/3.
Okay.
All right, 2/3. So half of that is minus 1/3, and now we're going to square it,
Right.
which is 1/3 times 1/3 times top to top. 1 times 1 is 1.
6.
9. 1 9.
9. 1 9. Positive or negative?
Positive.
Positive. A negative times a negative is a positive. So 1 9. So we're going to add 1 9 to both sides.
Yes.
Okay. Notice that when you complete the square, you're going to always be adding a positive number. It's never going to be a negative number when you complete the square. Okay. Now we don't even have to think about this. We already know what it is. It's x plus 1/2 of that squared is equal to, now we got to combine these two things together.
Yes.
What's 7/3 in terms of ninths? If you have 7/3, how many ninths do you have? If you have 7/3, how many ninths do you have?
60. Not 60.
If you have 7, you're given
21.
7/3 of a pizza. You're going to cut those thirds up into ninths. How many slices of pizza are you going to have? In other words, you're going to take each one of those and cut your thirds, each one into 3 pieces. 21. This is the same thing as 21 ninths. Okay. 21 ninths, negative. In our case, we had a negative here, so negative 21 ninths, right? Negative 21 ninths plus 1 ninth is equal to
22.
negative 21 plus 1 is
Oh, 20. Negative 20.
negative 20 ninths.
I didn't see the negative.
Weird. Okay, now take the square root of both sides, and so I get x minus 1/3 is equal to plus or minus the square root of negative 20 over 9. Right?
Okay.
Now, move the 1/3 to the other side, so x is equal to 1/3 plus or minus the square root of negative 20. What's the square root of 9? 3. What can we do with the square root of negative 20?
We can,
Is there a perfect square in there?
yes.
4.
4, 5.
4. So if we pull the 4 out, it becomes a 2,
2 times.
leaving behind a 5. So this is equal to 1 plus or minus, we're pulling out the 2.
Yes.
So 2 square roots of, we're left with a 5 in here.
Yes.
And we still have our negative. I'm going to pull the negative out and it becomes I. The square root of negative 1 is just I. All over, still 3.
That's how. So that's how you plug it,
We could have pulled the square root of negative 1 out.
right? Right. I'm just saying, like, we've gone over. I talking like this.
Yeah,
Because it's-
we don't want to have square roots of negative numbers.
Right.
Good. So, yeah, I bet he uses an I in his answer.
Okay.
Oh, he does 2I squared to 5. It's bad practice to put the I in the middle like that. It's better to put it at the end. I guess he wants it to be clear that the I was no longer under the radical. So maybe that's what he's thinking. But same thing. Okay. So there was 9.3. That was a bit of a toughie. All right, 9.4, quadratic formula. Here's a formula you guys are going to use left and right so you never have to complete the square and never have to think about anything I just taught you. So, if I give you any expression where you have it in the form ax squared plus bx plus c is equal to 0. So get everything on the same side is equal to 0. I don't know what the a's are, the b's are, the c's are. I'm going to show you how you can always solve any problem like this. And you no longer have to think in your head, oh, what adds to what to give this number and multiplies together to give this number. And you don't even have to do the completing of the square that we just did in the previous section, although it's good for you to understand. You can just always use this formula to solve every quadratic equation. And I'm going to derive the formula for you. How you can always figure out what x is, no matter what a, b, and c are here. With me? Okay. And I'm going to go through the process similar to what we did in all those previous problems. I'm just going to use a, b, and c instead of all these other things. So first thing we did when we were trying to complete the square is if we had something in front of our x squared, we just divided everything by that a. So let me divide everything by a. So I'm left with x squared plus b over a x plus c, oh, and I'm going to move my c to the other side,
So negative.
is equal to negative c over a. You with me?
Yeah.
Negative c, and now I divide everything by a.
Yes.
Yep, let's take it one step at a time. Sorry. So first thing, we have x squared plus bx is equal to negative c. Let's move the c to the other side.
Oh.
Now divide everything by a. Oh, sorry, there's a name there. Now divide everything by a. And so I get x squared plus b over a x is equal to negative c over a. Now we're completing the square. What number do I wish was there? Well, how did we figure that out? We took half of this number. What's half of b over a? It's b over 2a. That's half of b over a. Double the denominator. That's how you half something. Now square, which is equal to b squared over 2 squared gives me 4, a squared is a squared. So I'm going to add b squared over 4a squared to both sides. Plus b squared over 4a squared plus b squared over 4a squared. With me so far? Now, this is a perfect square. I don't even have to think about it. That's going to be x plus half of this thing, b over 2a. All squared is going to be equal to this thing. I'm going to change the order, and I'm going to get a common denominator. So I'm going to multiply this one top and bottom by 4a. So I'm going to take c over a, and I'm going to multiply it top and bottom by 4a, 4a. Why am I doing that? In the top, then I get 4ac,
So you get a common
and in the bottom, I get 4a squared. And so it's telling me to get my common denominator with this. So, writing this term first, that's b squared over 4a squared, minus, getting a common denominator, this is the exact same thing as this. 4ac over 4a squared. So we got a common denominator. Now, take the square root of both sides. So over here I'm left with x plus b over 2a is equal to, plus or minus, the square root of this whole thing. B squared minus 4ac all over 4a squared. Now I can take the square root of 4a squared, and what do I get? What's the square root of 4? What's the square root of a squared? A. So I get 2a. So move this to the other side and take the square root of that. So I'm going to get x is equal to, moving this to the other side, that's negative b over 2a. And I'm going to have plus or minus the square root of b squared minus 4ac
all over 2a.
all over 2a. Have a common denominator there, and finally we get x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And there it is. The quadratic formula. And now, it doesn't matter what I give you, you can always just plug it directly into that formula. Plug in your a's, whatever was right there, that's your a. Whatever was right there, that's your b. Whatever was right there, that's your c. And this will just spit out the right answer. In general, there's 2 equations you can expect students to know when they get out of high school. The first one is the Pythagorean theorem. The second one is this. X is equal to negative b plus or minus the square root of 4ab all over 2a squared. Or all over 2a. Sorry. You're going to need to memorize that formula. Yes, you 100% want to memorize this formula. I'm telling you, it's going to become your best friend. It's how you can solve these problems every time. Don't even have to think about it. I'd like you to think about it, but you can always and forever use this. So now we're just going to solve a bunch of problems using this over and over again. So he gives us our first problem. So I'll leave the formula there, but erase everything else.
Okay.
And we'll just crank through the problems that he gives us. So he gives us a problem, x squared plus 3x plus 2 is equal to 0. Here's my a. My a is 1. Put a 1 there if it's getting confused, you're not having anything there. A is not 0, it's 1. So 1, there's my a, there's my b, there's my c. So x then, I automatically know is equal to negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. Or in other words, x is equal to negative 3 plus or minus the square root of, what's 4 times 1 times 2? 8. What's 9 minus 8? 1. What's the square root of 1? 1. All over 2. Or in other words, x is equal to, take the positive case, negative 3 plus 1 is negative 2 over 2 is negative 1. Take the negative case, negative 3 minus 1 is negative 4, negative 4 over 2 is negative 2. So x equals negative 1 or x equals negative 2. You can always and forever just plug straight into this formula and it'll spit out the answer for you.
And you don't.
This one would have been easier to solve just by factoring, but the point is you can always do it. Factoring doesn't always work. Completing the square, well, that does always work, so that's what this is using, but it's a surefire way, always and forever, to get the right answer. All right, let's do it with the giant messy one now.
Okay.
So, we've got this one. So he has 25x squared is equal to 30x plus 11. Now
It's gonna be
this formula only works if you get ax squared plus bx plus c equals 0. So first you have to move everything to the left-hand side, then you can just plug into your formula. So this is 25x squared minus 30x minus 11 is equal to 0. Now we can just plug in. So x is equal to negative b, so now it's plus 30 because it's negative b, plus or minus the square root of b squared, which is 900, minus 4 times a times c, all over, we can get rid of that plus sign since it's positive, all over 2a. Right? Now we're just simplifying. So then x is equal to 30 plus or minus the square root of, let's see, what's 4 times 25? 100. What's 100 times 11? What's 100 times 11?
1,100.
1,100. So we have 900 plus 1,100.
Which equals 2.
200.
What did you just say?
So we have 900 plus, negative and negative gives us plus 1,100.
Oh.
1,100 plus 900 gives me
1,000.
2,000.
Oh, sorry.
1,100 plus 900 is
I
2,000.
thought.
Or 2,000. Okay. We good so far?
Yes.
All over 2 times 25. Huh? 50. Okay. Now let's see. Obviously we have 100 in here. So we can pull a 10 out. And obviously we have a 4 in here. So we can pull a 2 out. Or in other words, we have a 400 in here. When we pull it out, it will become a 20. So this is equal to 30 plus or minus 20 square roots of. Pulling 400 out of there leaves us 50 behind, right? All over 50. Now divide everything top and bottom by 10. Cancel out 10s top and bottom. Do. So we're left with 3 plus or minus 2 square roots of 50. All over 5. 50, does that still have a perfect square in it?
Yes.
25, so we'll pull that out. So pulling that 5 out, we'll be left with 3 plus or minus 10 square roots of 2 all over 5. We do that right?
Well, if you bring out, oh, you brought out 5. No.
Yep.
Okay.
So getting rid of 25 to bring out the 5. And check to see if that's what his answer is. 3 plus or minus 2 square roots of 5 over 5.
We took out.
Oh,
10.
400.
We took out, yeah.
400 goes into 2,000
Right.
5 times. Sorry. That was awful. Sorry. So that was 50, and then we cancel out 10 top and bottom, and so this is 3 plus or minus 2 squared to 5 over 5. I wonder how I left a 5 in there and didn't see it before. Okay, that makes more sense. Which is what he got. Okay. Next one. He gives us a big convoluted mess. What are we going to do? We're just going to put everything on one side and add like terms. And then we just plug it to the formula. Oops, I erased the formula, but we already have it memorized, right?
Yeah.
Negative b plus or minus the square root of b squared minus 4ac all over 2a. Memorize it. Okay, so writing it out. So we have 3x squared plus 4x plus 8 is equal to 2x squared plus 6x minus 5. Okay, put everything on one side. So I've got 3x squared minus 2x squared gives me just x squared. I have 4x minus 6x gives me minus 2x. I have 8 minus negative 5 gives me positive 13. Right? So I moved everything to one side, and now we just blindly plug into the formula.
Alright.
X is equal to negative b,
Which is just b.
negative b.
Oh yeah, I'm saying when you bring it.
Our b is negative 2.
Right.
So this is negative b. Don't get confused and think your b is just that number. It includes a sign. Okay, so negative b plus or minus the square root of b squared, negative 2 times negative 2 is positive 4, minus 4 times a is 1, times c is 13.
Right.
All over 2 times a, which is just 2 in this case.
Okay.
Okay. So now this is equal to 2 plus or minus the square root of 4 times 13 is
75.
how many cards are in a deck?
Oh,
52. Huh? You were getting there. Okay. So now subtract 4, and we're left with negative 48.
Yes.
All over 2. All right, what can we pull out of 48?
4.
What's a perfect square that we can pull out 48?
4.
4. So if I pull the 4 out, what do I get?
12.
So I get 2 plus or minus 2 square roots of 12, and then put the I at the end, because I'm also going to pull out the negative.
Yes.
All over 2, which is equal to, cancel out 2 top and bottom, and I'm left with 1 plus or minus the square root of 12i.
With no remainder. Right.
No remainder. That's
Yeah.
just it.
Because we can.
Yep, everything our denominator completely canceled out. 1 plus or minus, oh, duh. Why are we leaving our 12 there? Let's think for 5 seconds. This is 1 plus or minus the square root of, 12 has a 4 in it, so cancel out the 4 gives us 2 square roots of 3i. Okay, sorry about that. Getting sloppy. All right, and another problem, same thing. Maybe we'll do this one, just so you don't get caught up in the fact that we're missing a term. So this time we have 3x squared plus 7 equals 0. How do we solve this one? So it's going to be x is equal to negative b. What's my b?
7.
So in general, we're looking at ax squared plus bx plus c equals 0. What's my b in this equation?
You don't.
7's my c. 3 is my a. What's my b?
Oh, x squared.
I can rewrite this if that is throwing you off. Let's just rewrite this as 3x squared plus 0x plus 7 equals 0. If I add 0x, I change anything? No. What's 0x? It's 0. Okay, so now what's my b?
Nothing.
0. 0 is my b. So x is equal to negative b plus or minus the square root of b squared
0.
minus 4ac
Just 7. 3. 7.
all over 2a. Just blindly writing it out, right?
Yeah.
Okay, so x is equal to plus or minus the square root of 0 squared is just 0, so forget that. Let's see, what's easier? Easiest way to multiply these out, maybe these two first. 4 times 3 is 12. 12 times 7 is
4.
84. So this is negative 84.
2 times 3 is 6.
Well, actually, we're going to want to pull that 4 out, so
Because we
make it a 2.
Right.
But we'll leave it like that for a second. Okay, this is equal to plus or minus, pull the 4 out, so we have, that becomes a 2 square roots of, we're left with 21 in here,
Right.
I, pulling out the negative sign, all over 6. Finally, 2 and 6 cancel out, just leaving a 3 in the denominator. So x is equal to the square root of 21i
All over 3.
all over 3.
Yes.
That should have been his answer. So, if you're missing a term, it's just 0.
Yeah.
Plus or minus square root of 21i over 3. Huh?
Why does he keep putting the I up?
He puts the I in front. I think he's trying to make sure you don't accidentally think it's under the square root, just because of typing. Okay. 9.5, quadratics. Build quadratics from roots. Example, the solutions are 4 and negative 2. Oh. So
it's giving it to 4.
this time it's telling us what our answers are,
And we're trying to
come up with the equation that that's supposed to solve.
Okay.
So he's telling you, look, x equals 4 and x equals minus 2 are the answers as to what makes our equation equal to 0. Right? And so I know my factors must have x minus 4 must be a factor, because when I plug in 4, it has to give me 0. And I know that x plus 2 has to be a factor, because when I plug in negative 2, it gives me 0. So I know that x equal to 4 has to satisfy it, and x equal to negative 2 has to satisfy it. So now we just multiply this out, and our answer is going to be x squared. We get minus 4x, but plus 2 gives us minus 2x. Negative 4 times positive 2 is negative 8 equals 0. So x squared minus 2x minus 8 equals 0. That's what he's looking for. So you're just reversing these problems. You start with what you know the x's are. That tells you what your factors have to be. Then just multiply out your factors. So this is in general an easier thing to do. All right, let's do it again. Our solutions are x equals 2/3 and 3/4. So x equals 2/3, x equals 3/4. That tells us that
has to be x.
x minus 2/3 has to be 1, and x minus 3/4 has to be 1. Equals 0, and now just multiply it out. X times x gives me x squared. We have minus 2/3 x. We have minus 3/4 x. And then plus 2 times 3 gives us 6. 3 times 4 gives us 12. Equals 0. Okay. We got to get common denominator for these two. What's our common denominator going to be? 12. So this is going to be x squared minus, in terms of 12ths, this is going to be 8 12ths. Multiply top and bottom by 4. 8 12ths x minus, multiply top and bottom by 3. 9 12ths x, and then 6 12ths is obviously just 1/2, right? Equals 0. And then finally combine these two. 8 and 9 gives me, 8 and 9 gives me
Oh, you're adding. No, you are 17.
minus 17 over 12 x plus 1/2 equals 0. Should be his answer. Oh,
You gotta go
he
down.
doesn't want any fractions in the denominator. Aesthetic choice, but it's a perfectly fine thing to do. So he's going to multiply everything through by 12. So when I multiply that by 12, I get 12x squared. He's just getting rid of all his denominators.
Okay.
Multiply this by 12, we get minus 17x. Multiply this by 12, we get, remember this used to be 6 over 12, so multiplying that by 12 just gives us 6. And that's his answer, right?
Yes. He doesn't.
Oh, that's not the end.
'Cause he didn't.
Okay, here's his final answer.
Are you fine with us
Having it with the fraction answer? I'm fine with that on test. Just on your homework, if you don't write it this way, when I read out the answer, you might think you got it wrong even though you got right. So I would do it that way just for the sake of making get better scores on your homework. Because it's really hard to look at that and hear that and say, oh yeah, I did it right. But on a test, for sure, I prefer this. But you can do it however you want on the test, and I'll figure out that it's the same. All right, let's do another one. He says the solutions are square root of 3 and minus square root of 3. So x equals square root of 3,
Yes.
and x equals minus square root of 3. So what are my two factors?
It's gonna be x subtract.
X, oh, okay. X minus square root of 3
X plus square.
and x plus square root of 3. Now I see that that is just a squared minus b squared is a minus b times a plus b. Or you can multiply it all out. Either way, you're going to get x squared minus 3 when you multiply that out.
Yes.
Is equal to 0. And there we go. X squared minus 3 equals 0. Okay, I think you get how to do those ones. See if there's a tricky one. Let's do one with some i's in it, just in case. Okay, this time the author says the solutions are x is equal to 4 minus 5i, and x is equal to 4 plus 5i.
So your first one would be x,
X minus that thing.
so it'd be plus,
So it's going to be minus 4 plus 5i.
okay,
Just distribute your negative through, right?
okay. Next one would be
Times.
x.
If that's throwing you off, let's just write it like this. And then I think this will help you. So this is probably a better way to write. Let's do x minus parentheses 4 minus 5i
Okay. And x plus,
times
plus,
x minus, it's still minus, right? 4 plus 5i.
yeah. Okay. They're both minus, yes.
Because if you plug that in right here,
Right.
you get 0. And if you plug that in right here, you get 0. Okay, so multiplying this whole thing out, what are we going to get?
X squared.
The x times x is going to be the x squared. Ooh, that's going to get ugly, isn't it?
Yeah. How does he do it?
Let me, see if I'm doing something stupid here.
He just gets rid of,
The solutions are 4 minus 5i and 4 plus 5i, x equals that. Isolate the ith term. X minus 4 is equal to, okay, he's doing this trickier way. Okay, so I'll walk you through what he's thinking here. This is more clever. So I know that my two solutions are x equals 4 plus or minus 5i,
yeah.
right?
Yeah.
Okay, so he says we're going to get the I by itself, so I'll subtract 4 for both sides. X minus 4 is going to equal plus or minus 5i. Now, I think he's going to square everything. Square both sides. So over here, what do we get? When we square this, we're going to get x squared minus 8x plus 16 is equal to, when we square this, positive times positive squared is still positive, negative times negative squared is still positive. So when you square both sides, get rid of your plus or minus signs.
Okay.
And so we're left with just 5i squared,
Or
or negative 25, right?
It says 25i squared.
Oh, well, we haven't squared it yet.
Oh.
So over here, we still have x squared minus 8x plus 16 is equal to 5 times 5 is 25. I times I is I squared. But I squared is the same thing as negative 1, so that's just negative that.
Okay.
Now I'll move the 25 over, so plus 25 to both sides, and we get x squared minus 8x. 16 plus 25 is 41. Did I do that right?
Yes, because you moved to 16.
So that should be his answer. X squared minus 8x plus 41. Yeah. Okay. Let's try another one like this. So our two solutions are going to be x is equal to 3 plus or minus 5i all over 2. Can do the exact same thing. Multiply both sides by 2. We're going to get 2x is equal to 3 plus or minus 5i. Bring the 3 over. We're going to get 2x minus 3 is equal to plus or minus 5i. Now when we square both sides, get rid of our plus or minus. So 2x minus 3 squared is equal to 5i squared. Okay, over here, 2x times 2x is going to give me 4x squared. 2x times negative 3 is negative 6. And then negative 3 times 2x is negative 6. Add those together is negative 12x. Negative 3 times negative 3 is plus 9.
Right.
Is equal to 5 times 5 is 25. I times I is negative 1. Negative 25. Move it to the other side. 4x squared minus 12x. 25 plus 9 is going to be 34. 0. And check that that's what we got. Yes. Okay, that was 9.5.
Yes.
Maybe we'll just go through 9.6 today and call that good.
Okay.
All right. Quadratics in form.
Is it
Are
basically
we
the same
taking
thing?
homework today?
I guess not.
Sort of.
Last section. Last section, we're going to be given problems like this. X to the 4
Yeah.
minus 13x squared plus 36 is equal to 0. Now, we want this in the form ax squared plus bx plus c is equal to 0. Right? Did I lose y'all? Is this too much to do in one day?
It's not.
You dying?
No.
You got a spring break. Hang in there. One more section, then you're on spring break.
Almost.
Let's see some grit.
Okay.
All right. This has a 4 and a 2. We need a squared and a 1. And then we know how to solve this. We can just use a quadratic equation if we can get in this form. So here's our trick. We're going to do a substitution that gives us our squares here.
To make it so we can.
So I'm going to say, I'm going to call y equal to x squared.
Okay.
Now, rewriting that, x to the 4 then is the same thing as y squared. Minus 13x squared is the same thing as y. Plus 36 is equal to 0.
Oh, all right.
Now I can just use my quadratic equation. And I know that y is equal to plus or minus, or not plus or minus, sorry, negative b
Negative, right.
plus or minus the square root of b squared
Negative 30 squared. Just 169.
minus 4 times a times c
36. Right.
all over 2a.
Right.
Okay, so this is equal to, we have 13 plus or minus the square root of, let's see, what's 4 times 36?
44
144. 169 minus 144,
is 100.
not 100.
Sorry, it's just 2.
You got it, it's on the tip of your tongue.
25.
Yep. Square root of 25, all over 2. What is the square root of 25? 5. So this is equal to 13 plus or minus 5 all over 2. But we were not looking for y, we were looking for x. So in other words, x squared is equal to 13 plus or minus 5 all over 2. And now we can solve for our x.
Okay.
Maybe we should split this up. I wonder if he splits it up into 2 separate things as he goes. Yes, he does. Okay, so we're going to split this up. So x squared equals plus or minus that. Let's just handle the positive case and the negative case and break this up, rather than handling all the cases in one go.
Alright.
So x squared is equal to, if we take the positive case,
Okay. You have 18.
then we get 18 over 2 is equal to 9, right?
Nice.
And if we take the negative case,
Alright.
13 minus 5 is,
8.
over 2 is 4. Okay, so now I'll solve each of these. So x squared equals 9, what does x equal?
3.
Plus or minus 3.
Plus or minus.
Plus or minus the square root of 9, which is 3.
Okay.
3 times 3 is 9, negative 3 times negative 3 is 9.
So it's
Similarly-
x plus or minus 2.
Plus or minus 2. So when you have a fourth power here, you're going to have 4 solutions.
Okay.
And so here's our 4 solutions.
Okay.
Make sense?
Yes.
Okay, let's see. Another one. Different type of problem, but it's going to have the same idea. So here I have a to the negative 2 minus a to the negative 1 minus 6 is equal to 0.
Right.
Now, I want that to be a squared. I want that to be a power of 1. That's not what I have. Same thing. I'm going to do a substitution. I'll keep using y's for my substitutions just for consistency. I'm going to let y equal a to the negative 1.
Okay.
So then this is y squared minus y minus 6 is equal to 0.
Yes.
Okay, now just use the quadratic formula. I get y is equal to negative b plus or minus the square root of b squared minus 4ac
Negative 6. Right.
all over 2a.
Right.
Okay, so y is equal to 1 plus or minus the square root of, what do we get here?
Negative 24.
Negative times, so that gives you a positive 24, right?
Right.
Plus 1,
Just like that.
25.
All of 2.
All over 2, which is equal to
Just 5.
1 plus or minus 5
Right.
over 2. Let's just break it up. So y is equal to, take the positive case, 1 plus 5 is,
6.
over 2 is,
3. Plus or minus 3.
well, if we take the positive case, it's 3. Now let's take the negative case.
Yeah.
1 minus 5 is,
4.
1 minus 5 is? 1 minus 5 is?
Oh.
If you have $1 and you owe me $5, what's your net worth?
-4.
Which makes it -2.
So -4 divided by 2 is -2. Okay, there's our two answers for y. But we weren't looking for y. We were looking for a. And so I know that a to the minus 1 is equal to 3. And I know that a to the minus 1 is equal to -2. What does a equal? Flip the reciprocal on both sides.
Okay.
Look, a to the minus 1 is the same thing as 1 over a.
Same thing as a fraction.
Oh, okay.
A to the minus 1 is the same thing as 1 over a. Flip the reciprocals on both sides. That means a is equal to 1/3 and a is equal to minus 1/2. Those are your two answers. So, 1/3 minus 1/2. Okay, similar thing here. You have, let's make that a little bit bigger. Don't know it's worth walking through this one. We're going to move everything to the same side.
Okay.
We're going to divide everything through by 2. Or you can leave the 2 there if you want. Then we make our substitution, y equals x squared. Right?
Yes.
And then go from there. So you're going to have, if we make the substitution y equals x squared, we're going to have 2y squared plus y minus 6 equals 0. Use the quadratic equation from there. Same thing. Good?
Yes.
That looks like it kind of turned to a mess. So maybe this is ugly for some reason I don't see. So let's actually work through it. Because that didn't come out as pretty as I was thinking. Okay, so we're starting with this. So I'll just write that over here. We have 2y squared plus y minus 6 equals 0. Let's use our quadratic equation. Y is equal to -b plus or minus the square root of b squared
1.
minus 4ac all over 2a. So that is equal to -1 plus or minus square root of, over here, unknown, because we have the 2 there.
Oh.
So 24 times 2 is 48, plus 1 is 49,
Right. All
over 4, which is going to be equal to -1 plus or minus 7 over 4, right?
Right.
So I get y was the same thing as x squared, so now I'll write as x squared. X squared equals, in the positive case, what do we get? -1 plus 7,
8.
-1 plus 7,
Negative.
6,
Yeah.
6 over 4, which is the same thing as 3 over 2, right?
Right.
And then we get x squared is equal to, take the negative case, so -1 minus 7 is -8, divided by 4 is -2. Okay, over here, take the square root. We're left with x is equal to plus or minus the square root of 3 over 2.
Yes.
Oh, he probably doesn't write it that way, so he's probably going to write square root of 3 over the square root of 2. But now I need to multiply top and bottom by square root of 2
Okay.
to radicalize my denominator. So this is going to be plus or minus, he most likely has square root of 6 over 2. I bet is his answer.
Okay.
For one of them, that was using this, now let's use this. Here, I get x is equal to plus or minus the square root of -2, right?
Yeah.
Which is equal to plus or minus the square root of 2i.
Okay.
So those should be our two answers. I'm not sure what he ended up doing, but there it is, plus or minus
Yeah.
that and plus or minus that. So I'm not sure what he did in the middle there. Looks like he made a bigger mess than we did. Maybe he was trying to show you could still solve this using different ways. So that was disappointing. I thought we were going to run something tricky. The example here. Okay, this is a cool one. So let's do this next one. This next one, he has this written out in a very telling way. Now, one thing we could do, the stupid way to do this, is I could square that out, and then I could collect all my like terms, add everything together, and get the answer, and that would work.
Which is just do.
We could do that.
Okay.
We're going to be a little bit more clever.
Okay.
I'm going to say, I'm going to let y equal x minus 7. Now I'm going to rewrite this.
Oh, I see.
So we have 3 times y squared
Subtract 2 times
Minus 2y plus 5 equals 0. Now use our quadratic equation. Y is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so this is equal to 2 plus or minus, let's see, what do we have here?
16.
4 times 3 is 12, times 5 is 60. So we have negative 60 plus 4.
Right. Which is just negative.
Just want to double check I didn't write anything wrong there. I thought this was going to come out to 64, and it's not. It's coming out to negative 56, right?
Yes.
Which I would have guessed it was supposed to come out a perfect square. I am not sure how he is solving that.
Weird. Using foil.
He's not using the quadratic equation at all. Oh. So following it through with the way that we were doing it, plus or minus, make sure I don't have a sign mess up there. That's for sure positive, that's for sure positive, right? Okay, comes out how it comes out. So let's see, all over 6.
Yes.
Okay, what can we take out of 56?
7, 8, 37.
So, is that 14 times 4?
Yeah.
So if I pull out the 4, I'm left with the 14 in there. So this is equal to 2 plus or minus 2 square roots of 14i all over 6. So we're left with 2, or cancel out the 2's top and bottom, 1 plus or minus the square root of 14i all over 3. Because I cancel out 2 top and bottom.
Right.
Now this is what y is equal to. So this is what x minus 7 is equal to.
Okay.
So plus 7 to both sides. And x is equal to 7 getting it over 3. So get a common denominator between 7 and 3. 21 plus 1 is 22. 22 plus or minus the square root of 14i all over 3. That seems too messy. Let's see what you got. X equals 26 thirds.
And 6.
We're doing something obviously dumb.
Did we do some?
Or else he cheated in a way that I'm not seeing.
We got 56, wouldn't we?
Because I would have expected that to be a minus 5. Let's look through his thinking. He says we're going to have y equals x minus 7. So y squared equals x minus 7 squared. That's fine. I have 3y squared minus 2y plus 5 equals 0. He factors this. Let's see if his factoring comes out. Negative 5 times 1 is not positive 5. So he screwed up. I think he screwed up writing the problem. I think he meant for this to be a negative sign. This is what makes the most sense. Then his factoring here works. Negative 5 times 1 gives us negative 5 here. So I think there was a typo in writing the problem. I think he meant this to be minus, which is going to make our whole problem clean up. Because then this becomes positive, and this over here now becomes 64. And the square root of 64 is 8. So this becomes 2 plus or minus 8 over 6. So y minus, this is what y is. So y is equal to, take the positive case, 2 plus 8 is 10 over 6. 10 6 or 5 thirds. And then the other case we get is 2 minus 8 is negative 6. Negative 6 over positive 6 is negative 1. And now if that's our y, plug back in our x. So x minus 7 equals negative 1, or in other words, x equals 8. X minus 7 equals 5 thirds, or in other words, x equals, let's see, plus 7 get into thirds, so 21 plus 5 is 26 thirds. Did I do that right?
You got 26 and 6. There you go.
He got 26 thirds, and he got 6 instead of 8. Did I screw up?
Oh, with your 1?
2 plus 8.
Is it subtract the 7? Or is it positive 7? No. So how's it 6?
Let's see.
6. It's just 1. 6 over 6 is 1, which is just 6.
You got any-
Did he just mess up?
You probably got his answer wrong. Second one.
Oh, thank you. This is a 6.
Oh yeah, because it's
Negative 1 plus 7
right.
is positive 6. I'm as bad as you guys sometimes. You guys can't let me do that.
Oops.
All right. So there we go. Is that still working out that problem? Let's try one more of these where it's not square. Let's try cube one. Okay. So in this case, again, we're going to have to let the y equal something to make sure that we can work with this. What's my y going to equal?
Y is going to equal y.
It's going to equal what?
X cubed.
X cubed. If I let y equal x cubed, then now we have y squared minus 9y plus 8 equals 0. In general, it's just going to equal whatever this term is. That's a general rule. Because we want this to be 9y. So we get y squared minus 9y plus 8 is equal to 0. Okay? So we get y is equal to negative b plus or minus the square root of b squared minus 4 times a is just 1, we'll leave it, times c, all over 2a. So y is equal to 9 plus or minus, let's see, 81, and we're going to subtract from it what? 32? What's 81 minus 32? Come on before I write it.
50.
No?
49.
There you go. Okay, all over 2. What's the square root of 49? 7. So this is going to be equal 9 plus or minus 7 all over 2. So let's write out each case. And this time our y was x cubed. So I have x cubed is equal to, what's the positive case? 8. And what's the negative case? Negative 1 or positive 1? Positive 1. So x cubed equals 8 and x cubed equals 1. Take the cubed root of both sides. What's the cubed root of 8? 2. So I get x equals 2. Or I get, what's the cubed root of 1? 1. X equals 2 or x equals 1. First solution, x equals 1. Geez, what did he do? Let's stop for a second, because we only found one solution. Y equals x cubed. Yep, did that. X cubed equals 1, x cubed equals 8. We do need to do that. Okay.
Oh, we didn't plug it in.
No, we're good so far. Everything we did so far is great. So x equals 2 is a solution. So we got that. I forgot we introduced complex numbers. Once you got complex numbers, you're going to have as many answers as you have powers here. Okay. So the way that we find all those answers is we have to look at, so x cubed is equal to 8, or in other words, we get x cubed minus 8 is equal to 0, and we get x cubed minus 1 is equal to 0. And now we're going to factor these using our old factorings of, let's see, right where I'm still on lecture. I think I have it right up here now. So you might remember a ways back we talked about how to do perfect factoring of a cubed minus b cubed. You have a formula for that. And of a cubed plus b cubed. You have a formula for that. Here we have an a cubed minus a b cubed. Rather than think about that as 8, we're going to think about that as 2 cubed.
Okay.
And we're going to think about this as x cubed minus 1 cubed. Okay, so when you go back and you look at this formula, then you're going to get it's a minus b times, let's see if I can remember, a squared plus 2ab
Oh,
plus
that's right.
b squared. Is that right?
Yes.
Or is it just, what's that? Let's see, when I distribute this through, so we get a cubed, a squared b, ab squared, negative a squared, negative ab squared. So I think that's right. So this is one we want, right?
Yeah.
So factoring both of these, this is going to turn into x minus 2 times x squared plus 2x plus 4 is equal to 0.
Okay.
And then, when is this equal to 0? It's either when this is 0 or this is 0.
Yes.
So when is this 0? When x is equal to 2.
Okay.
So we already knew that solution, but let's write that again somewhere. We'll put our solution that we knew over here. So x equals 2 is one solution. Okay? Now we also need to know when this thing's equal to 0. So we gotta use the quadratic equation again.
Yes.
So really quick on this, when is this equal to 0? That's x equal to negative b plus or minus the square root of b squared minus 4ac.
Right.
So that's a 16 all over 2, which is going to be equal to, let's see, 4 minus 16 is negative 12.
Yes.
Pull a 4 out of that, brings the 2 out here. So I'm going to get negative 2 plus or minus 2 square roots of 3i all over 2. Cancel out the 2's. And so our other solutions to this are negative 1 plus or minus the square root of 3i. Okay. So that's working with this one to get its three answers. You do the same thing with this one.
Okay.
So 1 is for sure going to be an answer, and you're going to use the quadratic equation to get your other 2 answers. So that's where he's getting all these funky answers from. So the negative 1, so these 2 answers came from here. This answer came from there, and then if we would have factored this one as well, let me just erase this now since we've used it. Now factoring this one, that's the same thing as x minus 1 times x squared minus x minus 1 equals 0, right? 1 is our solution to there, so that's where we get the 1. And then finally, this piece is going to come from using the quadratic equation on this. So let's see that really quick. This is going to give us x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a, which is going to be 1 plus or minus the square root of 1 minus, or 1 plus 4, 5. He has a 3. Let's see, what did I mess up? Oh, these are all positive. Sorry. Right? From here,
Yes.
negative, all those are positive. Those should have all been positive. Sorry. So this is like that. Negative b, so that becomes a negative 1, plus or minus the square root of b squared minus 4 times a times c all over 2a. Okay, there we go. So this is equal to negative 1 plus or minus the square root of 1 minus 4 is minus 3, so we'll do 3 and then bring the I out
Right.
all over 2. Okay.
That's how I got it.
And why does it have a negative there?
Where? Plus or minus?
That should be a minus 1 right there.
No, because the 4 is negative and then you take.
Because it came from this,
Right.
negative b
Oh. it's
Plus or
also-
minus.
Yeah.
So just to be super sure, I'm just going to plug that into my calculator really quick and cube it and see if it comes out right. Because this should be, if this is my x when I cube it, I better get 1. So let me plug our answer in really quick and see if we get 1. Negative 1 plus the square root of 3 multiplied by I. Where are you? I, take all that, raise it to the power 3. And we do not get 1. Oh, because I didn't divide by 2. Take that whole thing, divide by 2, and I don't get 1. Let me try his answer. 1 plus the square root of 3 times I, rewrite it by times before, I wonder if that matters. All that, divided by 2, and let's cube it. Oh, my calculator just has a rounding error. It is giving me 1. It's giving me 1 with a remainder of 1. It's giving me 1.00001. So his answer's wrong.
Okay, you'd like me to call you 1.000000001.
Not by a mile.
Okay, I won't.
Very kind of you. Okay, so his is a typo. Ours is correct. That should be a negative. Okay. And that was 9.6.
Yes.
Okay, there's a good chunk for you to work on.
Why?
You have all of spring break. You get to go back and watch it. Lucky you.
There's other classes with homework.
Whose homework do you have?
And now there's one more. Hey, I didn't give you 9.7, so.